Hello everyone, welcome back to my additional mathematics channel. For today's video sharing, I will share with you one of the most important application of differentiation, which is the small changes, or in other words we call as the approximate change. So let's get started with the class. Have fun! Hello guys, today I would like to discuss the application of differentiation. So let's see question number 1. The period of oscillation t second of a pendulum with a length of L centimeter is given by t is equal to 2 pi square root L over 10. Find the approximate change in t when L increases from 9 centimeter to 9.05 centimeter. Alright, so you are given t is equal to 2 pi square root L over 10. So we can read as sub L over sub 10. We can split out like this for the sub, right? We have the rule for the sub. Okay, if dy, you can split out like this. So why we need to do so? Because we need to express in terms of the y equal to constant a x n, right? So sub L over 10 is equal to sub L over sub 10. Now why we need to do so? Because we need to split out the constant and the variable. So we have the two variable, which is period and the L, that actually I use the x. Alright, so I have to tell you first, my x is representing L. So I'm going to do dt dl, or I wrote as dt dx. Alright, so you must have the pattern of the power rule form, y equal to ax power n. Then 1 over 2 times the constant, which is 2 pi over sub 10. X half minus 1 is negative half, right? So that is how you differentiate the t with respect to L, dt dl, that show the changes with the period with the length, dt dl. Okay, so the two variable change in this way. So now you have to simplify as pi over sub 10 1 over sub L, right? So dt dl, or I use x, is actually pi over sub 10x. Okay, I join back using the sub rule. So now after I differentiate, dt dl is pi over sub 10L. I will substitute the L value, which is I call as x here. The original value must be using for the dt dx. Okay, you must use the original L, which is 9. Originally the L, the length is 9, and then it increased to 9.05, right? So that means from there you can find the delta L, right? So the delta L is 0.05. You just take 9.05 minus 9, right? After changes, minus original value, which is 9.05 minus 9. So the answer is 0.05 for delta L. And then you just substitute into the delta L. So dt dl is actually pi over sub 10L. I use x here, so you can use a L if you use it. So the L is representing x here, which is 9. So I am going to multiply with the delta L. So I will take the pi over sub 9t times 0.05. So the answer can be in terms of pi. If you want, you can times the value of the pi. It depends on the instruction of the question. So now I am going to use a calculator to solve 0.05 over 90. So you will get the answer in decimal, right? Okay, so let's work out the answer by using calculator. So what is the answer then? Alright, so I guess the answer should be around 5 point something, right? So it's actually 5.27 times 10 to the power of -3, right? Pi. So that is the answer for delta t, which is quite simple, right? So delta t is actually can be found by using dt dl times with the delta L. So this is how you work out the answer, 0.05 over 90 times with the pi, and the answer is 5.27 times 10 to the power of -3, right? So we have managed to solve one of the hot question for the small changes involving differentiation. Question number 2, the area of a drop of oil which spreads out in a circle increases from 4 pi centimeter square to 4.01 pi centimeter square. The circle is very important, so you circle the keywords. Alright, find the corresponding small changes in the radius of the oil. So we will write the formula for the area because we need to figure out how the area change with respect to radius. So the dA dr is 2 pi r. So after you differentiate, so then the original area is 4 pi and the area actually increased to 4.01. So from the original area, you can find the radius. The dA dr must be from original value of r, right? So r is 2, so you will solve the dA dr is 4 pi, right? So now the delta A is increased, so it should be the after changes minus the original value of the area. So it's 4.01 minus 4.01 pi minus 4 pi. So the changes for the area, the small changes, is just 0.01. So hence you can find the changes of the radius because you are given small changes of the area. So hence by using the delta A over delta R equal to 4 pi, I'm sure you can solve your small changes in radius, which is delta R. Alright, so let's write down the dA dr is approximately equivalent to delta A over delta R. Now we need to solve this. So let's find the delta R. So delta R should be actually multiplied by dAd, right? Is actually equal to delta A over dA dr. Alright, so you can write this way. So delta R is delta A over dA dr. Alright, so then we will just take the delta A, which is actually 0.01, and then divide by the 4 pi. Alright, now let's do it properly. 4 pi is equal to delta A, which is just now 0.01 pi. Make sure you write pi, 0.01 pi over the delta R, right? Okay, so then don't forget the 0.01 pi over the delta r, and then you just solve your delta r. The pi can be cancelled out, so delta r is 0.01 over 4, which is equivalent to 0.02 pi, right? So we have complete question 1 and 2. So for question number 2, okay, we will actually do it systematically like this. Delta A over delta R is equal to dA dr, and then delta A was given 0.01 pi, so you just over the delta R, and then you just cross multiply, because delta R can be found by using 0.01 pi over dA dr, right? Okay, so it's actually quite simple for this question. It's just that you need to cross multiply carefully so that you can get the answer perfectly. So then we will try to solve it and get the answer for delta R. I'm sure many students are wondering how to get the original values of R. So whenever you want to use the radius, you must actually start from the original area, which is given 4 pi, right? So from the you just do your imagination. You have the circle area 4 pi, and it will change to 4.01 pi. So of course, from the original circle, you will obtain the values of the radius, right? So always use the original before changes value to find the radius. So hence, you can solve the pi r square equal to 4 pi, and you can solve the radius, right? Because the radius that you use must be from the original circle, right? R square is 4, so R is plus minus 2, but because radius is a magnitude, so we will choose R equal to 2, and we will substitute. Alright, so you will actually substitute into the dA dr, so you will get 4 pi, and then you will solve the delta R by cross multiply. Again, I highlight to you the radius value must be from area which is before changes, or original value of the area. So hence, if you solve it, you will get the answer like just now I shown. Okay, is actually 0.01 pi over 4 pi, and you cancel out the pi, you will get the answer in decimal. Alright, so that is how you solve the small changes of the radius. Okay, bear in mind that always use the original value to find the unknown. Alright, now we will discuss question number 3 and 4. So let's get started with question number 3. The length of the side of a cube is x centimeter. Find the small change in the volume of the cube when each side decreases from 2 centimeter to 1.99 centimeter. Alright, so before you start, you try to sketch out the cube, label all the side with the X, okay, so that you are aware that this is the original cube that going to change. Alright, so the volume will be equivalent to x cubed. Okay, so we need to differentiate to find how is the changes of the volume with the side, which is x. So we will do dv dx, and then the side, okay, the side was decreased from 2 to 1.99. So that means the delta x must be negative value. So you should take 1.99 minus 2, which is negative 0.01. Okay, remember the small changes is always after changes minus the original value. Alright, okay, or after changes minus the before changes. After changes is 1.99, before change is 2 is original, okay, original length of the side. So now you need to do dv dx, which is 3x squared. Alright, and the value of the x you substitute must be from the original value of the side. The original cube come with a side 2 centimeter. So when you differentiate the changes of the v with respect to x, the x must be the original value, which is 2, right? You substitute into there, so you will get the answer for dv dx is 12. And then by writing the formula delta v over delta x equal to dv dx, hence you can find your delta v easily. Just take the dv dx times with the delta x, which is 12 times negative 0.01. So the answer is negative 0.12. It's simple, right? Okay, so most important is you must aware that you have to choose the original value for the differentiation. Okay, hello guys, that's all for today's sharing. Till then, I shall see you in my next video sharing. Bye bye and have a nice day.